Hi, I'm Mr. Miller, and this is video 2, Evaluating Algebraic Expressions. I want to give you a bunch of examples so you're ready to tackle all kinds of assignments related to this evaluation. All right, so here we go. We have an expression here. We have 3 times, that's what that dot means, box plus 7. What we're supposed to do is put different numbers in the box and figure out what the expression is equal to. The value of the expression depends on what we put in there. So for instance, we're going to put in 12 inside the box. If we do that, we get 3 times 12 plus 7. That would be the value of the expression. 3 times 12 is 36 plus 7, well, that equals 43. What if we put 25 into the box? Okay, well, we would have 3 times 25 plus 7, which ends up being 82. We can put negative numbers in as well. In fact, we can put any sort of number we want into the box. We just have 3 times negative 7, or 6, plus 7. If we grab a calculator and do that, we get negative 18 plus 7, which I think you end up with negative 11. Okay, well, let's try some others here. So here we have 6 times, and we have this quantity, whatever we put in the box, minus 5. All right, so again, the value we end up with depends on what we put in there. So if we put in 12, we get 6 times the quantity, 12 minus 5, and if you do that on your calculator, you get 42. We can put decimals in there also. We get 6 times 9.5 minus 5. Well, that'd be 6 times 4.5. I believe that is 27. So I'm going to double check here. I got my calculator here. So this whole course, we're going to need a calculator. Yep. All right, we're good. And again, we can put in a negative number as well. We have 6. If we put negative 4 into the box, we get negative 4 minus 5. That's 6 times negative 9, which is negative 54. We could have expressions where we put the number in more than once. Wherever we have a box, we're going to substitute our number. So if we put 5 into this, we would have 5 squared plus 4 times 5 minus 3. We put a 5 in both boxes. Okay, well, that'd be 25 plus 20 is 45 minus 3. It's 42. All right, let's get forward to the negative 2. We put negative 2 in the box, we have negative 2, and whatever's in the box, we're squaring it. That's why I put parentheses around it, plus 4 times negative 2 minus 3. I'll have more to say about these parentheses in a second, but whenever you raise a negative number to a power, you need parentheses so that you're raising the whole thing to that power. Negative 2 squared is negative 2 times negative 2, which is positive 4. This would be minus 8 minus 3, I think, is negative 7. All right, now, normally in algebra, we're not going to use boxes, but the idea of a variable is very similar. Instead of using a box, we're going to use a letter to represent an unknown number. Sometimes it's a number we're trying to figure out, and we just don't know it yet. We need to give it a name. And so it could be X, Y, usually any letter will do. So you'll see different letters as variables. But it's a symbol for a value we don't know yet. For instance, here, we're trying to figure out 4 times what number minus 7 equals 5. Well, we're going to learn to solve an equation like this very soon. So instead of boxes, we use letters, right? Like here. This means 4 times, well, what is X? Well, that's a good question. We have to give it a value before we can evaluate this. But whatever number X represents, we'll do 4 times that number plus 19. This is similar to what we just had by saying 4 times box plus 19 and just put numbers in the box. Same thing. So here, if we let X equal 17, then we have a specific number here and we can find the value. So 4 times 17 plus 19. All right, I'm going to do that real quick. I get equals 87. That's the value of the expression if we let x equal 17. Well, what if we let x equal 38? That just means we substitute 38 for x and then find the value. So we get 4 times 38 plus 19. That's equal to 171. We can put in a negative number. 4 times, we don't have to use parentheses here, but I'm going to do it anyway just to be careful. 4 times negative 26 plus 19. And we get equals negative 85. All right, so that's what we're learning to do, how to evaluate an expression. And pretty much it means take the values they give you for the variables, substitute them in for the variables, and figure out what the expression equals. So for instance here, we want to figure this out, what this expression equals when m is 8. So we're going to put 8 in for m, so we'd have 8. This means divided by 4 plus 7. Well, 8 divided by 4 is 2 plus 7 equals 9. We can put in negative numbers. This would be negative 20 divided by 4 plus 7. Okay, you can grab a calculator. That's negative 5 plus 7. That's going to equal 2. We can let m be 72 and figure out what the whole thing is equal to. All right, 72 divided by 4 is 18, and plus 7 would be 25. All right, here's another one. 8 times p minus 14, our variable is p. Well, if they give us a value, we can put it in. I'm going to jump to the very last one, because we haven't done a decimal, I don't think, on this slide. So 8, we're going to let p be 7.25. So 8 times 7.25 minus 14. We could also write this as 8 parentheses. That means times 7.25 minus 14. So 8 times 7.25 minus 14 is 44. Okay, so that's the basic idea here. Sometimes we organize this as a table. We're going to make a table of values. We're going to use the same expression, but we're going to put different values of x in it. So that's no problem. We're just doing what we're doing. So on this first row, if we let x be 6, this means we'll have 3 times 6 minus 10. We just figure out the value. That's 18 minus 10 is 8. If you're using a scientific calculator, you can just use the cursor up, just replace the 6 with the next value, and hit equals. So if you're using a calculator like that, this can be pretty quick. 3 times 10 is 30, minus 10 is 20. All right, we're going to let x equal negative 7. So 3 times negative 7 minus 10 is going to equal negative 31. And if x is negative 12, we have 3 times negative 12 minus 10 is end up being negative 46. We're not, but we can actually start thinking about making a graph of these values, and that'll be coming later. All right, hang in there. We got a couple important things and then we'll be finished. So I've already mentioned this. It's important to be careful when we substitute negative values in for x. So we want to evaluate x squared plus 6 for x equals negative 4. So we need to put parentheses around the negative 4 when we raise it to a power, and then add 6. Negative 4 squared is negative 4 times negative 4. A negative times a negative is a positive. So that's positive 16 plus 6, which equals 22. So that was the right answer. This slide, I want to show you why it makes a difference. So this is what we just did. We put parentheses around the negative 4 and squared the whole thing. That's what we want. We want all of that number. Whatever we're putting for x, we want all of it squared. That means negative 4 times negative 4, which gives us positive 16. And when we add 6, we got 22. If we don't put the parentheses in, only the 4 gets squared. Your calculator will give you the different answer, and it's not the one you want. When we don't put the parentheses, it'd be negative 4, the minus, and 4 times 4 is 16. That ends up being negative 16, not positive 16. Negative 16 plus 6, which is negative 10, which is incorrect. So want to use this one. Minus 4 squared like that is negative 16. When we use parentheses, we have positive 16, and that's the one we want. All right, you'll hear your math teachers talk about that over and over again. The other thing I want to talk about is division. So here, we're going to put a 4 in for x in both the numerator and the denominator. And what you have to know about fractions like this is you need to simplify the numerator and the denominator first, and then divide. So the division symbol is a grouping symbol. It means that it's all of the numerator divided by all of the denominator. It's like we have parentheses there. Usually we won't put them there, but that's what it means. All of the numerator divided by all of the denominator. That'd be 20 divided by 2, which is 10. All right, so I got 2 last examples, and these are kind of things we expect you to be able to do. Where we have this expression here, we're going to substitute x equals negative 2. Well, I'm squaring negative 2, so I'll put parentheses around it. And to be honest, if you're not sure when to do it, you'll never be wrong if you always put parentheses around a negative number. All right, so negative 2 squared plus 7 times negative 2 would be 4 plus negative 14, which is negative 10. All right, on this one, it's division. So I'm going to substitute the values. 6 for x. I'm going to simplify the top and bottom first, and then divide. 16 divided by 2 is 8. Well, here's the journal assignment for you. You might want to do these in some notebook paper and show your teacher if you want. They can double check your work. Good luck on everything.